concepts video on absolute value functions. So the general structure of an absolute value function looks like this. So we have f of x is equal to x in these bar signs, and they're absolute value signs, okay? And so what this graph really is, because we all know that it looks like, okay, this standard graph looks like the following. We have a V kind of thing going on, right? So something that looks like this, right? And the origin is at 0, 0, if you don't have any transformations, right? Like translations or reflections or anything. This is the standard absolute value graph, right? But what really is this? Because we see from our graph that we actually have two linear functions kind of just squished together at this origin, right? So that's really what it is an absolute value squishes together two linear functions. So specifically, when x is greater than or equal to 0, if you think about it, if you plug in 0, you're just going to get out 0. So it just is x. So f of x is equal to x. And that is also true for any other positive number. Because if you plug in like a 1 per se, then the absolute value of 1 is still 1, and that's it. The absolute value didn't change your already positive number. Okay? So this is one of the parts of our graphs. This is actually the right part. Okay? And then when we have the other case, when x is less than 0, so when x is negative, then when a negative number is placed inside here, the absolute value sign turns it positive, right? So it makes it the opposite sign of whatever it was going in. Okay, and this applies to negative numbers, all right? So when x is less than 0. So then we have the f of x is equal to negative x. See that? So this is a line on its own, and this is a line on its own. So this second part, I'll just label it part 1, part 2. This is like part 1 of our graph on the right side, and this is like part 2, okay? So there are two linear functions, okay? So a common application of the absolute value is to determine the distance between 2 points, okay? So I'll just write that down. So determine distance between 2 points. 2 points. Okay, so the important thing is, and the reason being why it's a common application to this, is because distance, I'll just abbreviate dist, that means distance, okay? Distance is always positive. Just by convention, that's what we think of in our real life and stuff, is always positive. Like you don't say, oh, I traveled -2 miles today in my car. You just say, I traveled 2 miles in my car heading west, or you just give it a direction. But distance itself is a magnitude, which means it's always positive, okay? So here's an example. So we'll do a mini example here. So the distance, we can calculate the distance between numbers on a number line. So distance between, let's say the numbers 2 and 7, okay? So there are two ways we could do this using absolute value. So distance could equal the absolute value of 2 minus 7, because this gives us absolute value of -5, and the absolute value sign turns everything positive, okay? So this just pops out a +5, okay? Or we could do it the other way. Distance is equal to absolute value of 7 minus 2, which is equal to the absolute value of 5, which doesn't really change the 5, but it just spits out a +5 as well, okay? So we see here, because we have these absolute value signs, because we have those there, subtraction doesn't matter about the order, okay? So the order of subtraction does not matter when you have an absolute value sign there, because it'll correct whatever you have, okay? It'll turn it positive, alrighty? The absolute value sign, in effect, it does the work for us. Okay, so here's an example involving distance between two numbers. So we have, describe all values x within a distance of 4 from the number 5. Okay, so that's a little bit confusing. So what I like to do whenever I see a confusing problem is try to draw a picture when you can. So let's see, we have some kind of number line going on, right? And it says we're trying to describe all values x, which we don't know yet, so we can't draw those on our number line, within a distance of 4 from the number 5. So it looks like this problem is based on the number 5, right? So let's say, okay, so here's 5. Alrighty? And what we're trying to do is find all the values within a distance of 4. So basically we can go 4 this way, we can travel a distance of 4 that way, or we can travel a distance of 4 this way. Okay? And then there's this point at which that is exactly 4 on either side from 5. So we can't go past there. We're not allowed to go over here, and we're not allowed to go here either. Okay? So what we have to do basically is say, okay, so they use the keyword distance of 4. right? So that means we'll have to subtract something and use an absolute value sign. So the question is now, where does this 4 go and where does this 5 go in our equation? And is this even an equation anymore? Because it says within a distance, so that means like, well, is something exactly equal to? So here's the answer. So we're going to say distance, which is given by the absolute value of something being subtracted, right? So the distance, it says it's supposed to be within a distance of 4. So that means that our distance, this guy, whatever's inside our absolute value signs, has to be less than or equal to 4. Okay? So that would give you, okay, distance is, or whatever x is, that's within your distance of 4 from the number 5. So then the thing is, okay, what goes in our absolute value sign? So, you know how we use variables for things that we don't know, oftentimes, or things that change, right? So let's say this is x, and also this is x here, okay? It's a little bit weird to have them both at the same spot, but this is x, like, it just means it's a value that is 4 away from your number 5. So what we're going to do, I'll just give you guys the answer here and then I'll talk us through it. So we're going to write in x minus 5 because x minus 5, and then when you take the absolute value of it, that gives you the distance between your x value, wherever it is. X could be here, x could be here, x could be over here, whatever it is. It gives you the distance between your x value, your current x value, and 5. 5 is just a fixed number, right? So if this gives us the distance, this means that distance between our x value, and 5. And then, so I'm just going to write it in words. So that's the left side. So that means is less than, or equal to 4, right? And that's it. That's all they wanted us to find, was all values of x. And this is how you describe it, okay, with this inequality here. So this describes all values of x within a distance of 4. This is the distance part, and within means is less than or equal to from the number 5. Okay, so this is our answer right here. Okay, for this example, we're going to sketch this graph, okay? So basically all we have here is some kind of absolute value graph, but it's been shifted a little bit to the right or left, up and down, and been stretched, okay? So what I like to do first for any kind of graph is, if possible, you can find the vertex first, right? So vertex meaning, in our case, for the absolute value, right where that corner is, okay? So normally it's at 0, 0 for our traditional absolute value of x, but here what we have is some kind of shifting, right? So here, what this is x minus h, and then we have plus k, right? So where our vertex is hk, so that means that our vertex is now going to be at positive 3 and negative 2, okay? So now we can plot that first point, right? So let's draw our x and our y, and we have 1, 2, 3, 4. Let's say 1, 2, 3, 1, 2. So our first, our vertex is going to be at 3, positive 3, so it goes to the right 3 and down 2. So let's say our vertex is right here, okay? And then let's see, we don't have any negative signs in front of our x, so that means that we're facing up still, right? And there's no vertical reflection going on or anything. We also don't have a horizontal reflection either because we don't have a negative sign in front of the x either. But we do have this 2 in front, which let's see what that does. So that just means that we're going to vertically stretch by a factor of 2. So vertically stretch by factor of 2. Factor of 2. So what does that mean? Just for our purposes, for this absolute value sign, you know how I said it was an absolute value sign is essentially a graph, 2 linear functions or 2 linear graphs stuck together at the vertex point. So that the vertical stretch by a factor of 2 just means that our lines, the lines that compose our graph, are actually going to have a slope of 2 and negative 2 respectively, as opposed to 1 and negative 1 for our normal absolute value graph, okay? So that means that from this vertex point, we're going to go up 2 for every time we move over 1 to the left or 1 to the right. So that would be up 2 over 1 to the right, so here's a point, up 2 over to the left, and that's a point there, and then we can keep going, up 2 over to the left, up 2 and over to the right. So we have a V that looks like this. Let me try to connect the points here in what looks like a line. Okay, so there's one, and then let me do this side here, and there it is. That's our new graph, our f of x. Okay, so now a little bit of a new topic. We're going to solve these absolute value equations. So absolute value equations. Okay, so let's start with the basics. Let's say I give you an equation like this, and I say solve for x. And it's like, what? How do you get rid of the absolute value sign? So this is the way you do it. So the solution to this would be either x is equal to 4, like a positive 4, right? That would give you an equality there, because if you have absolute value of 4 is equal to 4, that makes sense, because that comes out as a positive 4. Or we could also have, or x is equal to a negative 4, because we also have this other case where if you plug in a negative 4 into the absolute value sign, then whatever you get out becomes positive. So you get 4 is equal to 4. And that also makes sense, right? So we have these two different solutions.